Okay, this is chapter 1 of American environmental history, and this is really prehistory. This is the story of how people first reached the Americas and what they did when they got here. And in this chapter, we'll discuss the regular climate cycles that produce ice ages and the changes that result from those ice ages. We'll discover Beringia, where the ancestors of Native Americans lived for thousands of years, and we'll talk about the first Americans. So this image is ice. Ice was central to the story of prehistoric America. This is actually the Perito Moreno Glacier in Argentina, which still exists today. So just to backtrack a little and kind of set the scene, history is about understanding the past, using the best resources that we have available. And as new tools and information about the past become available, history changes. In recent decades, scientific breakthroughs have made it easier to understand the immense, long period of centuries before people began leaving written records. This new information allows us to look farther back, and we've discovered that what happened a long time before the beginning of recorded history had a big influence on our lives today. A big part of this change in understanding the past, for Americans, for us, is recognizing that our continent's history does not begin with Columbus, or even with the Vikings, but with the stories of people who arrived in the Americas 10,000 years before the first Europeans, or more. America's deep past was once thought of as just a prehistory that had no bearing on later events or on the present. As we'll see, that view was mistaken. Now, humanity evolved in Africa over a period of about 1 million years, so a much longer time scale. When they left their original homelands, early humans first spread over the adjacent continents that they could get to on foot, as you'd expect. Over thousands of years, these humans settled nearly all of Europe and Asia. But they didn't reach the Americas, because during those early periods of expansion, the Americas were separated by wide, uncrossable oceans. You may be aware that a long time ago, the continents were all joined together in a landmass known as Pangaea. This is true, but this ended millions of years before the first humans evolved. By the time people came along, the continents and oceans were pretty much where they are today. The isolation of the American continents and the changes that occurred on them when global climate change allowed humans to finally reach them had a major influence on the beginning of our story. This animation that you're looking at now is an image of the breakup of the supercontinent Pangaea and the subsequent drift of its constituent parts that became the continents that we know today. And this took place from the early Triassic period to recent. So this is geological time spans, not the type of time spans that humans have existed in. Now, human expansion across the continents of the earth must have been an epic story of courage and tenacity. It's too bad that it all happened long before the invention of writing, which was, when you think about it, only about 5,000 years ago. So a very small period in the overall history of the earth or history of humans on the earth. So we can only speculate about what these people felt and thought about their adventures. Luckily, scientists have recently been able to tell us more about the environments that these humans faced, and even about the people themselves. So we can now see at least a kind of hazy outline of this prehistoric epic. The modern humans that scientists call Homo sapiens have been around for close to 200,000 years. And for all that time, they have been more or less physically and mentally identical to us. That's an important point to remember. Ancient people lacked writing and they lacked other technology that we enjoy today, but they had comparable physical and mental abilities. They looked like us, and to a great extent, they thought like us. A few scientists have even suggested that some prehistoric individuals may have been more highly developed in terms of physical and mental abilities than we are. After all, they had to survive by their strength and by their wits on a day-to-day basis to a much greater degree than many of us living in luxury today. Prehistoric hunter-gatherers, who we once pictured as little more than ignorant cavemen, adapted and thrived in conditions that we would have trouble facing even with our technology today. A cave woman might actually have had an easier time getting along in our world of Wi-Fi and supermarkets than we would have surviving in her world without all the modern conveniences that we depend on every day. Now, the people I'm calling humans in this chapter may include a wider variety of folk than you would expect. Until recently, it's been very common to reserve the term human for only the most recent branch of the evolutionary tree, Homo sapiens. It was thought there were extreme and obvious differences between us and our ancestors, that we were in fact different species. But as we learn more about our earlier ancestors, we're discovering that they're more like us than we had imagined. Neanderthals, for example, had bigger brains than we do, and they made stone tools similar to the ones made by neighboring Homo sapiens. This graph here is a chart of the human family tree, the genus Homo. Note that the connections are drawn in now, where Denisovans and Neanderthals contributed DNA to modern Homo sapiens, to us. And then the most recent addition is Paranthropus, which refers to robust Australopithecines in Africa that don't actually contribute to our family tree, but that developed sort of adjacent to the people who we take our ancestry from, and then ultimately died off. So these earlier people weren't as isolated from their Homo sapien neighbors as we had once thought. One of the biggest discoveries that geneticists have made in the past few years is that most humans carry genes from people like the Neanderthals and the Denisovans. Since the definition of a species includes the ability to breed viable offspring, then Neanderthals and Homo sapiens, who had children together, were clearly much more closely related than we'd once believed them to be. So it makes sense to expand our understanding of humanity, to include these people that our ancestors mixed with. Maybe we can even learn something from them as we discover more about their prehistoric lives. Now, this image is obviously the landing of Columbus. It's a painting by John Vanderlyn, which was commissioned for the rotunda of the US Capitol building in 1846. And it presents kind of the typical view of Columbus with his armored retainers with swords and guns, planting the flag of not only Spain, but Christendom on the New World, with the natives kind of cowering and hiding in the woods to the right. But consider America. For most people, even for many historians, especially historians of the past, American history began in 1492. Everything that happened before Europeans began exploring what we used to call the New World is still often considered to be prehistory. It's remote, it's unknowable, and it's largely irrelevant in many people's minds. But is it really? If you happen to be descended from the people who were here before Columbus, then you would probably disagree with the idea that American history began in 1492. And actually, outside the United States, most of the people in North and South America today are descended, at least partly, from people who were here before Columbus. But even if all your people came to America on the Mayflower or on a slave ship or passed through Ellis Island, there are still reasons why American prehistory is important and is an important part of your story. And we'll explore them in this chapter, but here are the highlights. The people who settled the Americas came from the same ancestors as the people who settled Europe. So in other words, we're all related. The people who settled the Americas made one of the epic journeys in the history of our species. So it's a great human adventure. And The early Americans who lived here before Europeans came developed 3 of the 5 most important foods that are still eaten throughout the world today. So they had a lot to do with creating the modern world that we live in and making it possible. So one reason that historians often skip over this prehistory is that most of its data comes from other fields of study. It's obviously much harder to know what happened a long time ago when people didn't leave written records or when those records have been lost. This is a problem not only in the Americas, but throughout the world. Historians have learned to rely on anthropologists, archaeologists, geographers, and linguists to fill in the gaps in their knowledge. And more recently, on climatologists, geneticists, geophysicists, and even people running satellite remote imaging systems to help piece together the stories of ancient peoples and of how they lived. As these sciences develop and as new techniques and data become available, our understanding of the remote past can change radically and sometimes very abruptly. For example, our understanding of human origins has changed quite a bit since archaeologists first began discovering the bones of our distant ancestors. The most up-to-date data available as I write suggests that there were several waves of human migration out of Africa. The most recent wave, the one that leads directly to us, began roughly 80,000 years ago. Before that, around 150,000 years ago, some type of disaster seems to have reduced the Homo sapiens population in Africa to a couple of thousand, or maybe just a few hundred people. This time period corresponds with the glacial maximum, that is the peak of the Ice Age, before the most recent Ice Age. So it's likely that changes in weather patterns and global climate altered global patterns of vegetation, which may have reduced the foods available to our ancestors or to the animals that they hunted. Scientists aren't sure of the exact cause of the population crisis. What they do know, based on genetic analysis, is that there was a choke point there and that we're all descended from those few thousand or few hundred Africans. The human population, the Homo sapiens population, recovered gradually, and some of the survivors began moving northward from their original homes in Central Africa as climate continued to change. Probably they were following the herd animals that they hunted. But our Homo sapiens ancestors were not the first humans to travel the world. Homo erectus left Africa 1.8 million years ago, and their descendants were incredibly successful. Homo erectus actually survived in East Asia until only about 40,000 years ago. So from 1.8 million years ago to 40,000 years ago, that's almost 1.8 million years, when they were finally displaced by migrating Homo sapiens. A recently discovered group called the Denisovans left Africa about 1.2 million years ago. The Denisovans settled in Central Asia, and they contributed a crucial gene to modern people living in Nepal and Tibet that allows their blood to absorb more oxygen in the high altitudes of the Himalayas. And the ancestors of the Neanderthals left Africa about 600,000 years ago. They thrived in what is now Europe for more than 500,000 years. And they contributed to the genomes of all modern non-Africans. Neanderthals were incredibly tough. They survived through several ice ages, and they only disappeared about 25,000 years ago, when they too were displaced by Homo sapiens, who some of the Homo sapiens actually mated with them and had families, and that's why we and all Europeans have between 2 and 4% of our DNA comes from Neanderthals. But in any case, by about 40,000 years ago, a population of Homo sapiens who were hunter-gatherers descended from the people who had survived that African population crisis, had moved up into the Eurasian plains and were living north of the Black Sea. And these are your ancestors, if you're Asian, European, or Native American. They used spears and fire and cooperation to defend themselves from predators, and there were a lot of predators. years in those days. And they were experts at hunting very large prey, huge prey animals, like the woolly rhinoceros and the woolly mammoth. The Eurasians' ability to adapt to life on the plains and on the tundra gave them an excellent evolutionary advantage when a new cycle of global cooling once again changed the weather, the vegetation, and the animal migration patterns. And these changes extended the hunter-gatherers' habitats across the whole Eurasian landmass, from the Atlantic to the Pacific. So let's talk a little bit about ice ages. Global climate had been very stable for an extremely long stretch of the Earth's 4.5 billion year history, including during the tens of millions of years when dinosaurs roamed the planet, from about 150 million to about 65 million years ago. But over the last million years, there have been a series of cyclical climate changes. Over the last 500,000 years, which is a period that we have much better data for, global temperatures have varied by about 10 degrees Celsius, or about 18 degrees Fahrenheit, in a regular cycle lasting around 100,000 years. And this graph shows it. The highest temperatures were about 3 or 4 degrees Celsius higher than now, and the lowest were 6 or 7 degrees cooler. And these are global averages, not local. On a global basis, a 6 degrees Celsius drop in average temperature is enough to bring on an ice age. And that's exactly what happened during the cold part of each cycle. Snow fell and didn't melt. Ice accumulated into glaciers that spread northward from Antarctica and into the southern oceans, and southward from the Arctic Circle to cover most of what is now Europe, all of Canada, and quite a bit of the northern United States, including where we live currently in Minnesota. The last time this happened, roughly 36,000 years ago, is when American history really began. So again, this chart shows the relationship between global temperatures and the Earth's volume of ice. The ice volume line, which is the bottom line, is inverted, so you can see how ice cover and temperature changes line up. When the temperatures fell, the ice pack grew. Notice that about 150,000 years ago, Earth experienced the frigid temperatures of a glacial maximum. That's the climate change that may have caused that population crisis in the African Homo sapiens that I mentioned earlier. As snow became trapped in glaciers, rainfall patterns changed in Central Africa, killing plants that had evolved under different conditions. Lack of food reduced the numbers of grazing animals and reduced the numbers of the humans who hunted them. Later, when the climate warmed, the Eurasian glaciers receded and opened up new grasslands for the herds, forcing hunters to migrate, following their prey. After expanding across Europe and Asia during tens of thousands of years of mild weather, our ancestors once again faced centuries of cooling, and finally, another ice age that began about 36,000 years ago. This climate change created new opportunities as well as new challenges. When global temperatures began to drop slowly at the beginning of the last ice age, the forests of Central Europe and Asia started to die out. Trees have a hard time adapting to big changes in climate. Slow-growing forests can't relocate to places with better conditions as easily as other shorter-lived plants can. The Eurasian plains lost their trees and became grassy steppes and frozen tundra. The onset of the Ice Age probably took centuries, and Eurasian hunter-gatherers gradually followed the grasslands and the animals that grazed them. People who would become the first Native Americans expanded slowly eastward from Central Europe across what is now Siberia, while other members of the same ancestral population expanded slowly westward toward the Atlantic. All of these people were descendants of those survivors who had left Africa between 80 and 50,000 years ago to live north of the Black Sea in Central Europe. This is a photo of a herd of caribou, and these Eurasian hunter-gatherers that I'm talking about probably migrated and in an effort to track and follow these prey animals, ultimately following them across the entire continents of Europe and Asia as the climate changed. So as glaciers expanded southward to cover Europe and Central Asia, the tundra actually in the northeastern corner of Siberia stayed relatively ice-free. Ice Age weather patterns seem to have dumped all of their moisture in snowstorms over northern Europe, leaving eastern Siberia frigid but dry, and in some cases even kind of mild and dry. The Eurasian plains people adapted to this climate. They lived in small hunting groups that followed herds of caribou and mammoths and woolly rhinoceros. And these animals provided the hunters with food and hides and bone tools and large bones for building. But the hunters didn't form any large communities that we know of, but archaeologists have found the remains of many small camps. They seem to have lived in clans. A thin, widely spaced population of Siberian hunters managed to hold its own in this harsh environment for thousands of years, hundreds of generations. By about 21,000 years ago, the Earth had reached the coldest point of that glacial cycle. Scientists call this the last glacial maximum, which I should mention means only that it's the most recent glacial maximum and not that it's the final one. There will probably be another ice age in this planet's future. But by the last glacial maximum, the Eurasians had already reached the northeastern edge of Asia. Archaeologists have discovered sites in eastern Siberia that are over 35,000 years old. One settlement near the Laptev Sea, called Yana RHS, was occupied 27,000 years ago. The Yana RHS settlement is located within the Arctic Circle at 70 degrees north latitude, near where the Yana River empties into the Arctic Ocean today. This is extremely challenging territory even today. But the area may have been slightly milder in climate when the Eurasian hunters lived there during the Ice Age. Excavations at Yana RHS have yielded stone spear points and shafts of woolly rhinoceros horn and mammoth ivory, very similar to objects found at similar sites in North America. That's because when these hunters got to what is now the edge of Asia, what they found there was not the frigid water of the Bering Strait and the Arctic Ocean that we'd see today. They found more tundra. So much snow had fallen during the last ice age that the glaciers were up to 2 miles thick, covering much of the northern hemisphere. Enough water became trapped in these glaciers that many of the world's largest rivers slowed to a trickle or stopped flowing altogether. Global sea levels fell by 120 meters. That's over 360 feet. And coastlines around the world expanded dramatically. Now, the problem that we're having today, of course, is going in the other direction. And just to give you an idea, for comparison, if all the ice left on Antarctica and Greenland suddenly melted, the oceans of the world would rise 60 meters from their current level, or about 180 feet. This would be a global catastrophe. But it's only half of the sea level change that was experienced during the last ice age. So this graph shows the sea level changes during the last ice age. Near the left-hand side, you can see the last glacial maximum, about 24 to 22,000 years ago. Sea levels were 360 feet lower than they are today, and people were able to walk from Asia to America. The stretch of ocean that separates Siberia from Alaska, the Bering Strait, isn't very deep. The continental shelf would have been exposed when sea levels had dropped by only about 50 meters. So by the time Eurasian hunters arrived at the eastern edge of Asia about 30,000 years ago, the tundra just continued eastward in a 1,000-kilometer wide strip of land that scientists call Beringia. Although in the past, the connection between Asia and America has been described as a quote-unquote land bridge, the term kind of gives you the wrong impression. There was nothing narrow or temporary about Beringia. And worse, the word bridge leads us to imagine that people were going somewhere, that people were deliberately crossing this area in order to get from one place to another place. And this is a mistake. Beringia was a place. It was nearly as wide as Alaska is today from north to south. And it lasted for 16,000 years, from about 28,000 years ago until about 12,000 years ago. That's 3 times longer than all of recorded history. So the Eurasian plains hunters probably lived in Siberia, Beringia, and northwestern Alaska for that entire time. The Eurasians, who hunted caribou and mammoths and other big game, from what is now Kamchatka to what is now Alaska, had no reason to really think any differently about the land that they were occupying. They were following herds of game animals, living as they had for thousands of years, for their entire history. It's important to understand that the people living in Beringia were not migrating to the New World. If they had been migrating, they would probably have brought more than just dogs, which people began domesticating from Central Asian wolves about 30,000 years ago. As far as they were concerned, these Beringians were living the way that their ancestors had lived for uncounted hundreds of generations. This image is a drawing that I did of what the coastlines and the glaciers might have looked like at the peak of the last ice age, about 25,000 years ago. It's obviously very speculative, but what I tried to do was look at what sea levels that were that much lower would have possibly exposed in terms of the shallow continental shelves and whatnot that surround some of these continents of the world. And you can see in the center there, north of the Pacific Ocean, that Beringia just kind of extends across from Asia into the top of what's now North America, and that people could have lived there, although they probably wouldn't have been able to get through, to get over the glacier into North America for quite a long period of time. So the most compelling evidence that Beringians weren't deliberately migrating into America is genetic. The most recent analyses by paleogeneticists seem to show that there was a long period, lasting several thousand years, when the ancestors of Native Americans kind of paused or parked themselves on the edge of the continent. And the likely explanation for this is based on that map, right? That the pause was due to this wall of ice that cut Beringia off from the rest of North America. People living during the Ice Age would have been very unlikely to climb up onto a 2-mile-high glacier and try to cross it, even if they knew there was anywhere to go. But beginning about 15,000 years ago, as the ice began to melt and sea levels began to rise, Beringians would have found themselves gradually cut off from Asia. There was still a narrow strip of land joining the continents until about 11,000 years ago. But the route back to Asia would have increasingly been over rougher terrain, former highlands and mountains, rather than over the wide, kind of flat country that the hunters had been living on for so long. The plains that the Beringians had spread across and had lived on for so long would already have been disappearing under the sea. This is an animation of what the change probably looked at over time. And you can see that at first it's kind of minor, and then when you get to about 13,000, 12,000 years ago, it starts to really speed up. So rising oceans created the coastlines of the modern globe and filled the Bering Strait by about 11,000 years ago. The people who expanded from Alaska into North and South America were part of that very sparse population of Beringia. They weren't really joined by any large migrations of additional Eurasians, although scientists have found some evidence of a couple of small migrations back to Asia, when some Beringians apparently returned to Siberia and then ultimately further on into Asia, carrying genetic mutations that they had developed in Beringia or even in Alaska. Based on the most recent DNA evidence, the entire Western Hemisphere, all of North and South America, seems to have been colonized from an initial population of fewer than 5,000 Beringians, who entered the Americas in more than one wave of migration. Once they reached the Americas, the Beringians, who at this point historians begin to call Paleo-Indians or even Indians, but who I'm going to call Americans. These people were then cut off from Asia and left isolated by climate change for over 12,000 years. As the Ice Age ended, glaciers slowly melted and retreated into the Arctic. Excuse me. But glaciers don't disappear quickly. The 2-mile-high walls of ice blocking southwestern Alaska began melting on their southern sides in what's now the US and Canada as the warm temperatures increased from south to north. But they remained pretty much an effective barrier in the north. However, on the Alaskan coast, ocean warming and rising sea levels attacked the edges of the ice, just as they're now doing, undermining the glaciers in Greenland and Antarctica. And you're seeing that daily and weekly on the news. Scientists don't know exactly when a coastal corridor opened up, or whether the Beringians walked south along the water's edge, or paddled in small boats or kayaks. What they do know is that by 14,800 years ago, the new Americans had reached the southern coast of Chile and set up a camp in a place called Monte Verde. Now, southern Chile is a long way from Beringia. The site that archaeologists have discovered on the banks of a small river is about 50 kilometers from the Pacific coast and about the same distance from Puerto Montt, which is a small city that stands at the southern end of the Pan American Highway. And it's one of the southernmost cities of Chile. The other end of the Pan American Highway is at Prudhoe Bay, Alaska, not far from where the Beringians probably began their journey. The official distance of the highway between Alaska and southern Chile is just under 30,000 miles. The coastal route curves more than the highway does. So if you hug the coast, the distance is even greater. It may have taken Beringian explorers 1,000 years to make this trip. Scientists don't know because they haven't found many camps or settlements along the way. And one explanation for that lack of archaeological sites could be that the rising sea levels at the end of the Ice Age may have hidden evidence underwater. And recent finds on California's Channel Islands may confirm that theory and may shed some light on the issue. We'll have to wait and see what they find. This map shows the two major routes into the Americas. First, the early one hugging the coast that brought people to Monte Verde by just under 15,000 years ago. And then the second one, which I'll talk about next. But first, archaeologists at Monte Verde found stone tools and scraps of mammoth and llama hides. They found log planks, wooden tent pegs tied with grass twine, and a wide variety of other plant and animal remains. Nearly a third of the plants found at Monte Verde were charred from cooking, which tells us that the new Americans who lived there had a varied diet that included a lot of vegetables. So about a quarter of the plants that paleoarchaeologists have cataloged were not from the immediate area, but had been imported to the site. Seaweeds were found, stuck to stone tools, that must have been carried from the Pacific coast, 50 kilometers away. Other plant foods had been brought from high altitude homes in the Andes, or from grasslands up to 600 kilometers away. It's interesting that more than half of these plants are still used by the Mapuche Indians of southern Chile as food, drink, medicine, or construction materials. So these people who lived there 15,000 years ago had managed very quickly to learn what resources were available in this new region that they had migrated to and to take advantage of them. So these early Americans were not only incredibly mobile, they were remarkably good at learning which local plants were healthy to eat. And this knowledge is even more impressive when we recall that as they traveled southward from Beringia, from Alaska, along the coasts of North America and then Central and then South America, the Beringians left an Arctic tundra environment that they had lived in for hundreds of generations and that they knew as well as you could know anything, right? But they passed into these strange new ecosystems. The explorers crossed the equator and experienced tropical weather for the first time in 1,000 generations, probably since people had left Africa, their remote ancestors. But early Americans were apparently very fast learners. According to a leading archaeologist, there has never been, no archaeologist has ever found a plant native to the Americas with any food or medicinal value that was not familiar to pre-Columbian natives. So Monteverde was a very unusual site, a very unusual find for archaeologists. Plant remains almost never last more than a couple thousand years. And even bones are rare at most American sites that are over a few thousand years old. Stone tools are actually the most common artifacts found. And scientists have been able to trace the movements of ancient Americans by the types of stone that they preferred and by the tool designs that they left behind. When making their tools, these ancient Americans usually chose very high quality minerals that could be accurately chipped into the sharpest, most durable points. Craftsmen actually often traveled hundreds of kilometers to particular quarries to find these resources. For example, dolomite from Texas, from the Texas Panhandle, shows up in spear points found in northeastern Colorado, 585 kilometers away. Blocks of chert from Ohio were carried 380 kilometers to Michigan to be chipped into points and blades. And we know that because we found the origin of the chert, and then we've also found the places where craftsmen had chipped them, and we know that by the debris that they left behind. The people who made most of the spear points found in North America used slightly different techniques from those that had been used by the Monteverdeans. Their style of chipping stone points is distinctive enough that scientists think it represents a new culture in North America, which they call Clovis, after the New Mexico town where the spear points were first discovered in the 1930s. Unlike the first migration of Beringians, who had traveled down the coast to Monteverde over 15,000 years ago, the Clovis people seem to have followed a land route that probably opened about 12,000 years ago as the glaciers receded. There were two major ice sheets covering the top half of North America, and as they began to melt, a gap opened between them on the eastern edge of the Rocky Mountains. Beringians still living in Alaska, who hadn't made that migration down the coast, would have been able at that point to walk onto the Great Plains of what's now northern Canada, following the animals that probably also migrated into these new temperate grasslands. And as the ice sheets melted and the path expanded, sea levels were also beginning to rise more rapidly. And the land route into North America seems to have opened up at about the same time that the route back to Asia began to close once and for all, as the water rose high enough that Beringia was finally completely submerged and there was no way to walk back into Asia. So archaeologists have found many Clovis points, all of about the same age throughout North America, leading them to believe that the continent may have been very quickly and completely explored by Clovis people in as little as maybe 500 years. There's a bit of controversy surrounding the relationship actually between Clovis people and other groups because Clovis was discovered first. And the discoverers have been a little bit reluctant to see Clovis people lose their status as the first Americans. It's unknown, and it's a source of ongoing debate, how many coastal travelers like those who made it down to Monteverde might have been in the Americas before the Clovis people. But the evidence is mounting. That remains like those of Kennewick Man or the skeleton of the girl found at Hoyo Negro are from people who lived in the Americas before the Clovis culture arrived. Some people have even suggested that small groups may have managed to cross the Pacific from Oceania or cross the Atlantic from Africa. And although these possibilities can't be ruled out, DNA evidence suggests that most of the ancestors of early Americans, of the people who became Native Americans, came through Beringia. The important point is that after countless generations living as hunters and gatherers in Ice Age Siberia, and then Beringia, and then Alaska, early Americans quickly adapted their lifestyles to a variety of new American environments. This rapid change may be related actually to a dramatic drop in large animal populations called the Holocene extinction. In just about 1,000 years, from about the time that Beringians entered the Americas, most of the largest mammal species died out. Predators, like the Beringian cave lion, the saber-toothed cat, what we used to call the saber-toothed tiger, the dire wolf, and the giant short-faced bear all disappeared. And most of the biggest prey species, like the ancient bison, the woolly mammoth, the mastodon, the stag moose, and the western camel also went extinct. Scientists disagree over whether humans played a role in this die-off, maybe through overhunting the animals, or whether climate change at the end of the Ice Age eliminated their habitats. In either case, the continent-wide extinction event had dramatic consequences on the people hunting these animals, and also on people who had been hunted by these predators. The disappearance of these species changed the American environment substantially. This picture is a skull of Smilodon, the saber-toothed cat, which lived in North America and South America from about 2.5 million years ago to just about 10,000, 11,000 years ago. Luckily for early Americans, they still had plenty of large animals to hunt, even if they weren't quite as big as the ones that had disappeared. The modern bison, for example, although it's not 8 feet tall at the shoulder, like its extinct ancestor, still weighs about a ton. And its habitat expanded rapidly as ice sheets and meltwater lakes gave way to grassy plains. Smaller quarry for early American hunters included deer, pronghorn, jackrabbits, prairie dogs, and freshwater fish and mussels. The Beringians had brought their dogs with them from Asia, as I mentioned. But the only American mammals that they were able to domesticate were llamas and their smaller cousins, alpaca and vicuña, which they used as pack animals and also for their meat and their wool and their hides. The Americans' lack of large domesticated mammals caused their societies to develop differently from African and European and Asian cultures that had beasts of burden, such as oxen and horses. And we'll talk about that more later. But luckily, these early Americans quickly found plants that they could expertly adapt to their needs. Farming was once believed to have developed in the Middle East at sites such as Jericho and Mesopotamia, 6,000 or 7,000 years ago, when the ancestors of modern Europeans, and incidentally the ancestors of the men writing the histories, were usually credited with the invention of agriculture. Then, responding to evidence of prehistoric farming in places like Africa and India and China, it was suggested that agriculture may have developed more or less independently in several regions of the world. But it was difficult to imagine how this kind of parallel development could have occurred, with people in different parts of the world not only making the same basic discoveries, but making them pretty much simultaneously. More recently, some scientists have begun to suspect that this confusion may reflect the difficulty in finding archaeological evidence, since plant materials decay in the ground much more quickly than arrowheads and stone spear points do. And some have suggested that we may have been thinking about agriculture wrongly. It now seems that agriculture probably began in a very gradual process that goes back much farther than we had imagined, to a time when hunter-gatherers began favoring certain plants, and then maybe weeding around them to help them grow. And then maybe transplanting their favorites closer to home. And this horticulture, or part-time farming, may have begun before our ancestors began to spread from Central Europe across Eurasia. And that would explain the seemingly coincidental parallel development of farming across the globe. A lot of regions may have each developed their own distinctive versions of what we now recognize as agriculture from this deep pool of common techniques. But whatever the original source of their knowledge, Monteverdeans were already experts at finding and using native plants nearly 15,000 years ago. And it didn't take long for their descendants to begin selectively breeding American plants into some of the world's most important staple crops. Maize, what we call corn in North America, was developed by Central American natives in what's now southern Mexico, beginning about 9,000 years ago. The Central Americans created the single-stem, large-eared maize plant that we're familiar with today by very gradually improving a native grass called teosinte. Year after year, the farmers saved seeds from the best plants, the ones with the biggest seed heads. Eventually, after generations of patient improvement, these seeds began to look less like grass and more like what we'd call ears of corn. And this process of selective breeding may have taken centuries. And along the way, actually, the maize plants lost their ability to reproduce by themselves. Modern corn seeds are trapped on their ears, and most of them will never germinate unless they're removed by people and then replanted. So corn has sort of evolved to be totally dependent on humans. So today, maize is the world's most important crop food. Corn feeds billions of people and billions of domesticated animals around the world and produces a wide range of materials for energy, plastics, pharmaceuticals, and other industries. Potatoes are even older than corn. Papas, as they're called in the Andes Mountains, were developed by South Americans over a period from about 10,000 to about 7,000 years ago in a high-altitude region of what's now Peru and Bolivia. Even today, markets in many Andean villages still sell hundreds of potato varieties that people outside the region have never even seen. South Americans bred potatoes for a wide range of uses. Farmers were freeze-drying potatoes for long-term storage thousands of years before these techniques were first discovered and recorded by Spanish conquistadors. Potatoes were among the first, quote-unquote, New World products carried back to Spain by the conquistadors. They were widely adopted by European farmers and had solved Europe's recurring famine problems by 1900. The British economist Adam Smith called Europe's attention to this in his famous book On the Wealth of Nations. He called attention to the fact that fields planted with potatoes instead of wheat would feed 3 times as many people. Potatoes remain one of the top 5 staple foods in the world today. Cassava trees are native to central Brazil, where they were first domesticated between 10,000 and 7,000 years ago as well. Although the product of the cassava tree, which is called manioc, is only familiar to most North Americans as the dessert food tapioca, the processed roots of this jungle tree are another of the world's top 5 staple crops. Manioc feeds billions of people in Asia and Africa. But unlike maize and potatoes, the roots of the cassava tree are actually toxic in their raw form. They contain cyanide compounds that have to be removed before the manioc can be eaten. Then the processing of this manioc involves grating, milling, fermenting, drying, and roasting the cassava roots in various combinations, depending on the particular end product that you're producing. So in addition to discovering this food, when they reached Brazil, early Americans had to develop processing technologies to make it actually usable. So that's quite an accomplishment. Learning to grow and store food plants, in addition to hunting, created a huge change. It changed everything in the Americas, just as it had in Europe, Asia, and Africa. Nomadic hunter-gatherers who had always followed herds of prey animals began to be able to stay in one place, literally putting down roots with the crops that they planted. Abundant, regular food supplies allow populations to grow. Soon, people were building the ancient cities of the Americas that still amaze us today. Like their cousins in Egypt and India and Asia, early Americans built remarkable cities. Tiwanaku, which is located near the shores of Lake Titicaca in the Bolivian highlands was built about 3,500 years ago. Its 30,000 inhabitants developed a farming technique called flooded raised field agriculture. And they covered the hills around the lake with walled terraces. And this is especially impressive because the Tiwanakans were working at very high altitudes, some of the highest altitudes that people have ever lived in. The water level of Lake Titicaca is at an elevation of 12,500 feet, and the irrigated hills around the lake rise from there. So in the 12,000 years that they were cut off from the rest of the world, early Americans developed a variety of civilizations. Many of these cultures existed simultaneously, and trade networks developed that were able to carry items like Upper Michigan copper, New England seashells, and Minnesota pipestone across entire continents. Cities such as Cahokia in what's now Illinois, Machu Picchu in Peru, Chichen Itza in Mexico, and Pueblo Bonito in Colorado are just a few of the most visible, well-known remains of ancient native cultures. By the 15th century, when the Americans would once again encounter their European cousins, the Western Hemisphere was probably equal to Europe in both population and in culture. Civilizations rose and fell in the Americas long before the Americans and the Europeans met again in the 15th century. The Mississippian culture of North America seems to have peaked around 1200 in the Common Era and seems to have collapsed during the Little Ice Age. The Anasazi, or ancient Pueblo culture in southwestern North America, seems to have gone into a similar decline during this period of rapid climate change. The Mayan culture of Mexico flourished between about 1800 BCE and 900 CE, so lasted for over 1,000 years. There are several theories about Mayan decline, but the consensus seems to include a combination of overpopulation and agricultural collapse, possibly brought on by increasing aridity and desertification, possibly also by disease. In South America, the Inca Empire called itself Tawantinsuyu, which means four parts together in the native language, referring to the four distinct ecological regions, as well as political regions, that the Inca joined together to form the largest empire in pre-Columbian America. And many continuously successful regions, like the territory that was occupied by the Triple Alliance in central Mexico, the Aztecs in the 15th century, had been the home of earlier cultures, such as the Toltecs, who existed from 800 to 1000, and the Olmecs, who had existed from 1500 BCE to 400 BCE, that had been either conquered or absorbed by the cultures that followed. The Aztec or Triple Alliance capitals of Tenochtitlan and Texcoco in the Valley of Mexico each had more than 200,000 inhabitants when they were first discovered by the Spanish. Tenochtitlan was built on an island in Lake Texcoco, and it was connected to the lakeshore by a series of causeways. Each of the Aztec cities was larger when the Spanish arrived in the Americas than Paris, London, Rome, Venice, or Lisbon. In 1492, the region surrounding Lake Texcoco contained at least 1 million people. Mexico City, which the Spanish built on the remains of Tenochtitlan, was America's largest city when the Europeans arrived. It remained America's largest city in 1600 and in 1800 and in 2000. The urban Aztecs had a lot of people to feed. They farmed using what we might now call intensive gardening techniques. The Aztecs surrounded their island capital of Tenochtitlan with raised planting beds called chinampas on floating platforms that they built in Lake Texcoco. And this technique allowed the Aztec farmers to carefully control soil fertility and watering. The Aztecs supported 15 people per hectare using chinampas in the 15th century. That's about 5 to 6 people per acre. Chinese intensive farming, which was the most successful agricultural technique known to Europe and Asia, only supported about 3 people per hectare, so less than 1 person per acre at the same time. So these Chinampas and this Aztec farming was 5 or 6 times more efficient and effective than the best techniques known to Europe and Asia. So although North America had seen its share of city building cultures, and like the Mississippians who built Cahokia, the Central and South Americans seem to have been much more urban than their northern cousins. And they radically changed the landscape surrounding their cities. In addition to the Aztec Chinampas surrounding Tenochtitlan, the Incas built over 6,000 square kilometers of those terraced farms in the Andes. Surrounding Lake Titicaca in Bolivia were another 5,000 square kilometers of terraces, rising from that lakeside elevation of 12,500 feet. Dotting the eastern slopes of the Andes were cities like Machu Picchu, which was also surrounded by terraces that you can see in the shots that are a little bit wider angle. Many of these sites were covered, and their buildings and terraces were torn apart by rainforest trees over the last 5 centuries. And many of them, like Machu Picchu itself, have only been recently discovered in the 20th century. Even more surprising than finding new cities belonging to known American cultures is the recent discovery that some areas where it was never believed the environment could support large populations have actually hidden completely unknown cultures. The Beni region of Amazon, Bolivia, is now believed to have been the home of a culture that built raised islands on the river's floodplain. They connected their island homes with miles of causeways. And although remains of the earthworks actually survive, it was assumed that they were natural formations until just a few years ago, when archaeologists took a look at them on satellite images and saw the patterns, and then dug into them and discovered that they had been constructed from broken shards of old pottery. The earthworks and the canals of the Beni have still not yet been completely mapped and dug. The Amazon rainforest also had always been considered extremely inhospitable to civilization. The dense jungle, people said, just simply couldn't feed enough people. And if the rainforest was cut down to make space for farms, then the region's shallow soils were almost immediately exhausted. And that observation was made based on the experience of more modern farmers who do cut down the forest and then find themselves with useless lands after a season or two. But recently, archaeologists have discovered a city called Marajo, which was the home of over 100,000 people. Marajo thrived on the banks of the Amazon for 1,000 years. And instead of using slash and burn agriculture that people currently practice in the Amazon, the Marajoara turned the rainforest into an orchard. According to a recent study, the Marajoara grew 138 crops in the forest, more than half of which were tree crops, nuts and berries and fruits. And they fertilized their orchards with a charcoal-based supplement called terra preta, which can still be detected in hundreds of square miles of Amazon soils over 1,000 years later. So there's a heck of a lot more going on in the Americas than we had ever known in the past, and we're still just scratching the surface and finding out about it. So pretty exciting time for archaeologists and American historians. Meanwhile, in Europe, what about the other Eurasian plains people who had expanded westward from Central Asia, from the Black Sea towards Europe? We'll rejoin them, actually, in the next chapter. But one interesting thing that happened to them that changed the ancestral Europeans during their westward trek was they began drinking milk. Unlike the Americas, Eurasia was home to several large mammal species that people were able to domesticate. One of these species was the oryx, a grazing animal like a buffalo that stood about 6 feet tall at the shoulder. The wild oryx is now extinct. Although it was first probably hunted for its meat thousands of years ago, the oryx were different from other prey animals. Oryx were a social species, and some of them would actually accept humans as the leaders of their herds. The oryx could be bred in captivity, and they gradually lost their fear of people and even allowed themselves to be herded. Over time, in exchange for prime grazing land and protection from other predators, the oryx even allowed themselves to be milked. After hundreds of generations, the wild oryx, of course, became domestic milk cows. At the same time, some of the people who began keeping cattle developed a genetic mutation that allowed them to digest cow's milk as adults. This is not typical of most of humanity. It's really confined to the people who became Europeans and a few people in Africa who seem to have developed the same ability separately. The ability to metabolize lactose, the sugar compound in milk after childhood, is not shared by most of the rest of the world's people. In spite of the fact that cows have become familiar companions since the beginning of recorded history, it's useful for us to remember that recorded history covers only a tiny, tiny sliver of time. Nearly all the changes that made Native Americans different from Europeans when they met again in the Caribbean in 1492 happened recently, after the Eurasian hunter-gatherers, who were our ancestors, went their separate ways during the last Ice Age. So that's it for now. Next time, we'll talk more about how the Europeans found out about the Americas and what they did when they found out. So thanks for listening. I'll see you next time.